concepts. I want you to understand why. And so that when you get a problem, you know how to approach it. You don't have to sit there and go, All right, now, suppose I gave you the equation y equals x squared minus 4. All right, Dominique, could you describe that transformation for me for that graph?
It's a shift.
Yes, okay.
To the left.
What's your parent graph?
It's quadratic.
It's a quadratic, so it's just x squared, right? So once you've squared the value, you're dealing with the y value. So you're subtracting 4 from the y value. So what does that mean?
Is it shift to the left?
If it's to the y value, is it left or right?
Oh, it's down.
So you're shifting it down 4. Are you guys agreed? Yes or no? All right. So I'm gonna I want to quickly graph this for a so it goes to here. I'm not going to graph the parent graph. I'm just going to go for the gusto and get the graph that I'm looking at right now. So please graph it. All right, so there's the graph. Now, what did we call that point right there, Hudson? Okay.
Wouldn't that be like the vertex?
The vertex, or what's another name? That's correct. That's good.
Minimum.
What?
The minimum.
What else? That's true. Look at its position on the graph. What's it also called?
Oh, the y-intercept in this case.
The y-intercept. Okay, now, Hudson, what do you know about every y-intercept?
The x value is 0.
The x value is 0. You guys agree? Yes or no? Okay, Santino. So, what do you think these points are called?
X-intercept?
That is correct. Is the x-intercept. Now, here's the new part. They also have 2 other names, and they're used both in you'll use the in higher mathematics. They also call them roots, and they also call them zeros. They all mean exactly the same thing. So they're all interchangeable. It means exactly the same thing. So, Santino, what do you notice that's true about every x-intercept?
Y is 0.
The y is 0. Do you guys agree? So it's something 0. So in this case, would you guys agree that this point is 2, 0, and this point is negative 2, 0? Yes or no? Okay. So if you look at the equation, it's really easy to do this one when it's a graphable one, but how would you attack it if it was in this form and you didn't look at the graph? Is the question. Well, if I asked you to find the x-intercepts of the zeros, that means the y value is 0. Are we tracking? All right. Now you see that as a quadratic equation. Now, if the equals 0 had been covered up, if I could cover that up right now with my hand, and you just had the x squared minus 4, you would realize that is a difference of squares. Do we agree? Difference of squares? And you could factor it as such, and it would be x minus 2 times x plus 2. Do we agree? So what you're trying to do is figure out the values of x that you could plug into that equation to make the thing equal 0. Now, sidebar for a second. If I told you that a times b equals 0, Ethan, what do you know about a and what do you know about b?
Well, at least one of them is 0.
At least one is 0. Either a is 0 or b would have to be 0. What you're ever multiplying together, one of those would have to be 0. Logical sense? Agreed? So that means when you go back to this equation, that means that this equation right here, this part, has to equal 0, or this part has to equal 0. One of the two has to equal 0. And so in this equation, when you move 2 to the other side, you get 2. And when you move 2 to the other side here, you get negative 2, which turns out to be what your x-intercepts are. Does that make sense? Now, the reason you know to attack the problem this way, here's your memory device. What makes this equation different than this equation? What is the very big difference here? Anybody, go. Cole, what?
It's 2x, not x to the second power.
It's not x to the second power, perfect. So this is a linear equation. This is a totally different strategy. When you're trying to solve a linear equation, what you do is you move the numbers to one side, variables to the other, and then you simplify it. When it's a quadratic, you always set the equation equal to 0 and factor. Let me repeat that. And that sounds stupid, but this is a big issue. If it is a quadratic equation, which means that it has a power of 2 or higher, you're going to always set the equation equal to 0. Questions? All right, so now they're going to give you an equation. They're going to give you an equation. They're going to say y equals x squared plus 7x minus 8, and they're going to say find the roots, or they might say find the zeros. And as soon as they're saying that, Jake, what is that telling you about the problem? Jake? Yes, I was talking to you, yes.
Oh, I'm sorry.
We zoned for a second there.
Yeah. Wait, what did you say?
Oh, you have to listen to me, Jake. I'm so excited. Okay, if I ask you to find the roots of 0, what are they asking you to do? Are you talking for yourself? I rarely hear you.
Can you hear me?
Now I can hear you. This is you're muted. There you
Oh,
go.
I was. Oh, okay. You plug something in.
You plug something in. Jake, you are drifting. Pull up together, Jake. Pull up your socks. What is a root of 0? What's another name for it?
I forget.
Yeah. You're killing me. Justin, what's it called?
X-intercepts.
So what do you know about x-intercepts?
They're 0. Like there's something 0.
What's 0?
Like 0, y equals 0.
Why? Guys, you are killing me, Jake. I'm gonna hang you by your toes. You guys gotta pull your socks up and get your acts together. You cannot drift. You cannot drift on me. Focus. Sit up straight. All right. Do we agree on this? Talk to me. Yes. All right. Now, what is your attack strategy? Sydney, what's your attack strategy?
You factor it.
Good. How am I going to factor this puppy dog? Go. I'm ready. And where are the signs? What are the signs?
Is it negative, negative?
No. Try again.
Positive, negative?
Positive, negative. There you go. Finding a sum or a difference.
Difference?
Yes. What factors of 8 have a difference of 7?
Negative, what? I don't know.
Just factors of 8 that have a difference of 7. Why are there factors of 8?
8 times 1.
Bingo. There you go. That's all I need. So you'd have x plus 8, x minus 1. You guys hanging with me? Talk to me. I see one head bobbing. Thank you, Gio. I like it. Thank you, Gio. So you have the x plus 8 is equal to 0. The x minus 1 is equal to 0. So your x would equal negative 8. Your x would equal positive 1. Are we all good? Any problems? No problems. All right, now, keep on going. Now, they're going to say find the zeros. And they're going to give you this equation. Okay. Now this is a little bit different. They're asking you to find the zeros. All right. Kaden, take a stab at it. What do you think you're going to do if I'm asking you to find the zeros?
Do I have to change the form?
Like, what do you mean?
Or do I have to like subtract 4x from both sides
Why?
to make it all on the same side?
Why?
I don't know.
What was I told you? Do you guys remember what I told you? This is why I'm saying you gotta listen. What I tell you? I'm not disagreeing with you. I'm not disagreeing with you. But what was the strategy? Whenever you had a what? A quadratic or higher power, what's the first thing you always do if I ask you to solve it? You make it equal 0.
To 0.
Does that make sense, guys? So I'm gonna subtract the 4x over. Okay, thank you, Kate. Perfect. Are we good so far? Alrighty. Noah, what do you think you would do? Now,
Well,
I'm
first-
go ahead.
First, as always, I would think, oh, is there anything I can factor out? And that answer is a resounding yes, I can factor out x.
That's a high five. Okay, good. Well, again, factor out next. You guys all catch that? So you get 3x squared plus x minus 4. Now, are we all in agreement? So far, so good. All right. Mallory, what are your signs?
Is it plus minus?
Good. Are you finding a sum or a difference?
The difference?
Right, because the signs are different, you find a difference. All right, right. Factors of 3 are 3 and 1. Factors of 4 are 2 and 2, 4 and 1. The ones that work, that have a difference of 1 are 3 and 1 and 4 and 1. You would take the 3 times the 1 and the 1 times the 4. You guys hanging with me? Okay, so we would put the 3x and the 1x down. And then you put the 3 times the 1 and the 1 times the 4. You want a difference of a positive 4, positive 1, so it'd be a positive 4 and a negative 1. Yes or no? Am I good? I have to move to the next page because I ran out of space. Hang on. So it's x times 3x plus 4 times x minus 1. Did I copy it right? Is that right? Am I good? All right, now, there are now, you're trying to figure out what value you would plug in for x to make it equal 0. There are 3 values. This one, the second one, and the third one. Are we all in agreement? All right. So already this one is one answer. If it's a 0, it works. This one you would have, where does 3x equal negative 4? Because you move the 4 to the other side. So where does x equal negative 4/3? That's your second answer. Third answer is where x is equal to 1. Any questions about that right now? Any questions?
Can you explain how you got negative 4/3 again?
I pull the 4 to the other side because you're trying to isolate the x. So I subtract the 4 over and then I divide it by 3. Does that make sense?
Yeah, that makes sense.
Okay. Yes or no?
Yeah.
Now I can see you guys going right from here to your answers. I totally get that. You do not have to show these 3 steps. Does that make sense? I'm okay if you're doing that. You don't have to go through all this if you don't need to. Are we good?
On an actual assignment, how would you want us to like have this as an answer? Would you want us to like box each x equals?
I would just need to see, you could write it as x equals 0, negative 4/3, 1.
Okay, thank you.
Perfect. That'd be good. Does that make sense? All right.
So, in this case, are there 3 roots?
There are 3 answers that you can get that will make this equal 0. Yes. Okay. All right. Next one. All right. This is yours. I want you to try this. The equation is f of x equals negative 2x squared minus 6x. And I want you to find on you. And we'll come back. So go ahead and give it a shot. Are you ready? There you go. All right. Caleb, what'd you do first?
You gotta set the equation as 0, like equal to 0.
Great, perfect. You're good to go. Audrey, what did you do next?
Then I factored it. I factored out a 2x.
A positive 2x? Okay.
Yeah.
So then you have negative x minus 3. Are we all good? Reese, are you there? There you are. Okay, so Reese, what would you do next? Reese, there's this problem. I have really good ears, but not that far away. Reese, you weren't doing the problem. You were sitting there vegetating. Oh, now you're getting back into the game.
No, I kind of missed what you said the last part.
Yeah, so you need to be paying attention and not leaning back in your chair. I asked you, what's your next step?
Oh, the next step would go from that to the different parts would be the 2x parentheses. So it'd be 0 equals 2x.
How long were you gone?
I was here the whole time. I was writing all your notes down.
Oh, yeah, but you were drifting mentally, right?
Yeah, probably.
Oh, that's not good. You guys, what do I do? What do I do to keep you intact? What do I do? I mean, I've lost Jake today. I've now lost Reese. I mean, what do I do to keep you entertained? This is so hard. I'm trying everything. I mean, I could do things I can't do anything crazier. I'm doing this. All right, so here we go. Reese, follow me. You said every factor equal to 0. So 2x is equal to 0. You with me, Reese? So you divide by 2 and you get 0. You get minus x is equal to 3. X is equal to negative 3. Are we good?
I have a question.
Go ahead, Danny.
Going back to the top when you could like factor things out, is it possible to factor out the negative?
You could have factored out the negative.
Oh,
Those would have become positive. And then that would have turned to a negative, just like you have. This would have been here, but then you still have the same answer. So good
Okay.
question. All right. Now, I want to point out one thing to you. Jake, are you listening? Reese, are you there? Mentally. Okay, so I want to point now. Remember the problem back here where I told you you had to factor out the x? You guys, you with me? This is really critical right now. If that last problem I just did, you said negative 2x squared minus 6x, and you set it equal to 0. Notice I factored out the x, but this is really handy. When you have a number, you can actually divide the number out because you have an equation. You never, ever divide out the variable, okay? Because you lose an answer, but you can divide out numbers. It just makes them smaller. So if I divide it by a negative 2, I get x squared plus 3x is equal to 0. The advantage of this is that you get smaller numbers to deal with. So you would factor out an x, and you would get x is 0 and negative 3. Does that make sense? It's just another strategy. Do you follow what I'm saying? Head wagging really helps right now, and I know you're listening to me. Okay. We're good. All right, I love the head wagging. Sydney, that is just like, it's Sydney, you're not moving. Sydney. Ah. All right, so here's another one. Let's find the roots. 2 more and I'll be done. Find the roots, and you have 36x squared is equal to 9. All right? This is a little bit different. So Olivia, what do you think you would do first if I'm asking you to find the roots? Are you saying anything, Olivia?
She typed in the chat.
Huh?
She's
Olivia?
typing in the chat.
She's typing in the chat. Okay, I need to go see my chat screen. I can't see the chat screen because I'm on Zoom. What'd she say? But I can't tell, right?
She said subtract 9 and her mic isn't working.
Ah! Subtract 9 and thank you. Alrighty, are we good? Okay, Daisy, do you see anything you can do here now? You're trying to solve for the roots or the zeros or the x-intercepts, so what would be your next step?
Do you set it equal, well, it's already set equal to 0, but the 36x squared?
Equal to 0?
Yes.
Is it factored?
No.
So I can't set equal to 0. It has to be factored before I do that. Do you notice anything, Gio, that I could do to make my life easier?
Sorry, did you call on me?
Oh, I did. That's why I'm just,
Oh.
Where there's no head, that's kind of including me that you just sent it back into the position
But-
like this where you can't see me, right? Is this
Yeah.
what, can you guys even see me right now? I mean, okay.
Yeah, we can.
Okay,
But,
there. Okay, go.
I would factor out a 9.
Factor it out or divide it out.
Oh, I
What
guess
did I
you could
just-
divide it out.
I could divide it out. What did I tell you? Can you divide out numbers?
Yeah. 'cause
You
it's an
can divide
equation.
out numbers. So you can divide it out and you get 4x squared minus 1 is equal to 0. Are we in agreement? Yes, yes? Cole, what type of equation is that?
Quadratic.
Good. What type of quadratic? It has a very special look to it. Two terms.
Oh,
Minus
wait, say that again.
2 terms. Minus in between. You can take the square root of both terms.
I don't know this one.
All right, Evan, you guys are killing me. Wake up, smell the roses. Go ahead, Evan.
It's a difference of squares.
Right, remember guys, when you see 2 terms, you can take the square root of both of them. There's a minus in between. You know it is a difference of perfect squares. It should be identifiable within seconds. Do we understand?
I have a question.
Go ahead.
So, I'm confused. Why wouldn't you just divide 36 by, or like, do like 9 divided by 36 at first?
You could. So you would get 4x squared is equal to 1.
Oh, okay.
But if it's a
okay to do it that way.
quadratic, you could have done that, but you're still going to put it back. You're going to make it equal 0.
Yeah.
Okay.
Okay.
All right. So now we factor, we get 2x minus 1, 2x plus 1 is equal to 0. So x is a half, and x is a negative half. Are we there, guys? I'm only spending 1 night on this, just so you know. So you better get this down. We're plugging forward. This is not hard, but it does take time. All right, last problem. They're going to say given 2 and negative 3 are roots, find the quadratic equation. Okay, now you're going backwards. Given the answers, given the roots of the equation, go back and find what the original quadratic equation was. Does that make sense? Are you tracking? You're going backwards. So that means if 2 was the root, within the parentheses, it would have been x minus 2. Yes or no? Yes? Are we good? And if it was minus 3, it means that plus 3. And we're setting this equal to y because we're setting a quadratic equation. All right? So far, so good? Now, they expect you to FOIL this out. So if you FOIL it, you would get x squared plus 3x minus 2x minus 6, which gives you x squared plus x minus 6 is equal to y. Questions? Do we understand? Are we good to go? Any questions? Okay, I'm gonna let you go early. Kaden, can you stick around? All right, so you guys have a wonderful weekend. Be sure to work hard, and hopefully I will see you Monday.